Okay, today we're going to go through the EV3 sensors and talk about the basic operation on various sensors. So go to the Lego Mindstorms EV3 programmer software. I'll just open the project, and on the bottom you will see the programming palette. There are bunch of them. Of course, we've used the action and we used the control, and today we focus on the sensor blocks. So in the sensor programming palette, you will see various sensors. We'll talk about a few of them, not all of them. So first one, the color sensor. Okay, so color sensor can detect colors or detect the light reflection, or we'll learn later, it can also detect ambient light. So basically, if you pull up the color sensor, here you need to specify which port the color sensor is connected to. Choose one from 1, 2, 3, 4, whichever you connect to your robot. Let's use 1, and then you can specify in the mode selector to tell the color sensor to measure, to detect color or detect light intensity, reflected light intensity, or detect the ambient light. So there are three choices. You can either measure the color, measure the light, reflected light, measure the ambient light, or you can measure and compare. So basically it's two steps: to measure the light intensity and also do a comparison at the same time, and return the condition true or false based on whether the comparison is satisfied. Okay, so you can specify equal to, less than, not equal to, all this comparing function, and specify the threshold. Here you just measure the light, reflected light intensity is, if it's less than 50, then it will return true. This true value can be used to pipe into other blocks that needs this condition, and at the same time it will output the actually red light value in case it's a way less than 50, whatever it is, it will tell you. Okay, so that's color sensor. Of course, we also learned about the using to measure color. There's only I think there's only a bunch of seven colors to recognize. We'll see later. You can measure the color or you can compare the color. So compare the color, you'll see there are 7 colors supported. Actually 6 colors, including none. Okay. In order to get the color sensor work accurately, you have to place the detected color close enough to the color light, approximately within a half inch should be accurate, because otherwise it's too far, it's subject to environment, the ambient light noises, and also the sensitivity becomes weaker if it's too far away. So that's something you need to remember. So color sensor, you can also read more in the manual, the color sensor. Okay, in the EV3 programming help, you can go to the sensor blocks and choose color sensor, and then read some detailed operation on color sensor. Okay, next sensor we're talking about is the gyro sensor. So gyro sensor, gyro, by this look and feel, it to detect the robot rotate on this surface, displayed as the sign, the rotational sign. So it can measure. Of course, the first thing we need to do is to specify which port it's connected to. If you specify port 4, for example, then you make sure your gyro sensor is connected to port 4, and there are a bunch of operations supported by gyro, so you can measure the angle, basically the absolute angle of the gyro sensor, or you can measure the rate. So basically if you choose rate, that will measure how fast the robot is turning on the rotation surface. Or you can measure both angle and weight, and angle and rate. Of course, once you measure, you can use that number to finish some comparison. For example, you want to turn 90 degree, right? You want to, so if you start from 0 degree, then you just specify the gyro sensor angle is increase from 0 to 90, then it will be anytime in the past is 90 or beyond, you should tell the condition to be true. Okay, so that is using comparison. It's combination of a compare and measurement. And one special thing about this gyro sensor is it allows you to reset, because gyro measures angle, right? The angle keeps changing, and depending on where you started, then increased by 90 degrees, for example, it will be added on top of your initial angle. So you always want to reset the gyro sensor angle to be 0 before you make use of the angle. So you reset to 0, then after the gyro sensor change to 90 degree, then you can reliably use the end angle. And there is a one second, I think that's pretty much of course this reset only reset the gyro angle to be 0. It doesn't reset the rate. The rate will be reset when you power on the gyro sensor by turning on your robot. So you can read the help menu. Gyro sensor, gyro block, okay. That's gyro sensor. Next, we're going to talk about the motor rotation block. It's a built-in sensor. So you go to the palette and pull up this motor rotation, depending on which motor you want to measure. So motor B, for example. So basically, this is just like your human walking, right? Whenever you walk, you kind of know how many steps you have walked. You remember that. Same thing for the robot. The robot is turning the motor, and somehow it has a built-in mechanism to remember how many rotations or how many degrees the motor has rotated. It even knows how much power the motor is currently running, just like your body. You know how fast you're running. So for the motor rotation, you can measure the angle the motor has turned, or number of rotation, which is equivalent. Just one rotation equals 360 degree. And then also you can measure the current power of the motor. I think we used this in previous example. And same thing as other color sensor, other sensors. After you measure the value, you can combine it with the compare. For example, in our motor store detection, we use the current power, right? Whenever the current power is greater or is less than 45, if you run your motor at 50, you can use this condition to detect if the motor stored because of the bump or something, right? And whenever it's bumped, the motor stops turning, then the power eventually drops below 50, and then the condition will be true, and then you can do something based on that, right? And of course, if you are measuring degree, same thing, same as the gyro sensor, which measures the angle of the gyro. It depends on your initial angle and then how much angle you changed. Same thing here. If you are trying to measure the rotations or the degree the motor has rotated, you always based on your initial degree of the or initial angle of the motor and how much it has turned. So you can, before you can use the measure the degrees or measure the rotation, you always want to reset the motor rotation to be 0. Okay, so we reset. Once we reset to 0, and after the motor B, for example, motor B run for how many rotations? For 1 rotation, then you measure rotation, you must read the number 1. Okay, so that is the motor rotation. And next sensor we are going to look into is let's see, the timer. Okay, timer is it's also a built-in sensor from EV3 computer. So basically it's like your human body. You know roughly how much time has passed if you have good sense of time. So EV3 robot has very good sense of time. It has a built-in timer, and to measure how much time has passed, of course, before you use a timer, you always want to reset the timer. Okay, so here change the mode to reset. It will reset timer, and then from then on the timer will count from 0 and all the way up to the accurate time. In the timer we have eight timers to use. Okay, you can choose timer 1 through timer 8. So that means you have 8 different timers for 8 different purposes. Each timer can start at a different time, so on. And when you measure, you always want to use the right timer, reset the right timer, and measure the right timer to tell the exact time you want to measure from beginning to where you measure. And then the output will be the time, of course. You can display the time, or you can pipe it to other comparison to so measure the time, or you can do combine it with the comparison. Okay, so the timer. Next, we're going to look at the touch sensor. Okay, touch sensor. Go to the palette and touch sensor. Drag the touch sensor to. I'm going to start a new line. Okay. In touch sensor, you want to specify the port, of course, and you want to measure. You want to measure the state or compare the state. So basically, the touch sensor, there are 3 states. There are 3 states. So state 1 means the button, the touch button is released. State 0, actually state 1 means pressed, and state 0 means released, and the state 2 means bumped. Basically, you pressed and released. That causes a bump. So you can measure the state, whether the current state of the the touch sensor is pressed or released. There's no state of bumped, because bump is an event, it's not a state. So however, when you compare, you can compare the touch sensor whether it's pressed or it's released or it's bumped. And then based on the condition, it will return you true or false to match your specified action. And that then also it tells you the actual state of the touch sensor at the end. Okay, so touch sensor. Next, we are going to look at the ultrasonic sensor. Okay, ultrasonic sensor is to detect distance. Okay, so basically, it has ultrasonic waves sent from the devices from the 2 eyes, and then it echo back whenever it met some obstacle, and using the time to calculate the distance between the sensor and object. And you can measure the distance from the obstacle in distance in centimeter or distance in inches, or just whether there is obstacle present or not. Or you can also compare the distance. Another thing I want to show you is if you connected your computer to your EV3 to your computer, on the programmer on the bottom right view, you can see there's a to allow you to do the port view of your robot. So basically, here you have access to all the 8 ports A, B, C, D, and 1, 2, 3, 4. As we learned, A, B, C, D is connected to the motor. Here we have 2 motors connected. The big motor on B and C, and we have then the 1, 2, 3, 4 is a sensor port. We have 4 sensors connected: color sensor, and then ultrasonic sensor, and then touch sensor, gyro sensor. So basically, you can make use of this dashboard, the sensor dashboard port view, to help you to troubleshoot or quickly see what's happening with all your sensors, why it's not correct, why it's not the value you expected, and then you can change your program accordingly. Okay. So here, if you look at the color sensor, based on the color, what kind of color is put there, or here you can click a port view, click the color sensor, and then to change the input, whether you want to measure color. For example, we can measure color, and then for the color, it will tell you the color, and of course is the number of the color. You need to look up the table to see what 5 means. 5 actually means red, or if you point it as black, you'll see 1, or point it as white. Actually, find the green color, green, and you point it, you'll see 3. Okay, so the color, you can also change it to reflect the light intensity. So black, close to 0. Okay, if it's white, white, close to 100. Okay, usually the lowest should be 0, and the highest is 100, ranging from 0 to 100. Of course, you have to calibrate your color sensor. We'll talk about that later. And then this ultrasonic sensor. So basically, we connected the ultrasonic sensor to part 2, and then you move your hand closer, and then the distance decreases. And then you move away, then the distance increases. You can measure the distance in centimeter or measure in inches. Okay, easy, right? And then the touch sensor. So basically it measures the state. You can look at the state. 0 means released. Okay, if you press, it will be 1. Okay, if you release, it will be 0. There's no state of bump, because bump actually it's a 2 event. It's press and release. So you won't see state of 2. You will see either it's pressed or released. Okay. Now look at the gyro sensor. So gyro sensor measures the angle. Okay. If you turn positively, turn clockwise, the angle change increases. If you turn counterclockwise, then the angle will decrease. Okay. And then you can change the measure, whether measure angle or measure rate. Okay, if you measure rate, if you're not moving, the rate should be close to 0. But once you turn the speed clockwise, it will have a positive rate. If you turn counterclockwise, it will have a speed of negative rate. Okay, And all this sensor, you can for sensors that can be reset, for example, the gyro sensor, you can click the number and then it will be reset to 0. Okay, so that's a manual reset. Now let's look at the motor rotations. Okay, motor rotation, let's look at the motor B. Okay, you can measure the motor rotation in degrees or motor rotation number of rotations, or if it's running, you can measure the power. For example, if we measure the rotation, of course, before you can measure, before you can make use of the measurement, you always want to reset to 0. So you just click at the port, and then it will be reset to 0. And then if you turn positively forward, then it will increase. Okay. If you turn backward, it will decrease. Okay. Same thing for power for motor C. Okay. So that's easy. And so that's the sensor. We look at all the sensor. You can measure the sensor value, or you can measure and compare, or you can just look at the dashboard port view to troubleshoot the colors, the sensor values. And all this sensor measurement can be used in condition check. So basically, depends on the measurement, the value you read from the sensor, you can use that as the compare condition. You can wait for a certain value, so it can be used as a wait condition. If you look at using the wait block, you will see you can wait on the value of the brick button for a color sensor or gyro sensor or motor rotation. So basically it's a wait, but the wait for the condition when the specified sensor matches the target value or compare against the value. So for example, let's take one example. We measure the gyro sensor. Okay, we turn 90 degrees, right? So you can wait for gyro sensor, compare the angle greater or equal to 90 degree. Basically, you have to, of course, you have to reset to 0 first, and then you wait until the angle increase to 90. Or you can wait just the change of angle. Then you don't need to have the reset, because it just measures the change from the beginning of the wait to the end of the wait. Whenever you detected the final angle change increase by 90 degree, and then it will return exit from the wait. So that is wait condition. Same thing as we discussed before. The loop is just a more flexible wait. It also has all this condition. You can use any of those colors of those sensor measurement to build up the loop end condition. For example, same thing, we use the gyro sensor angle. Okay, angle greater or equal 90. Okay, same. Or you can use sensor in a switch. Switch also requires condition, right? That condition can come from any of the sensor measurement to compare the sensor value or measure the sensor value. And then, for example, if we use color sensor, right? So we read color sensor, we measure the color, and then the output of the color sensor will be the color, right? The color can be 0, 1, 2, 3, up to 7 colors, right? We learned about the earlier, so we can add cases, and then the first case color is default is black. Second one you can change to any of this. So basically, the cases really depends on the output of the color sensor reading. Okay.